So welcome to the another video for your chapter number 9, coordination compound. Today we'll start from the portion where we left in the last class. So I have already told you that your coordination compounds are these type of huge complexes. So now let's see where we ended in the last class. Here in the last class we ended with this slide when I was telling you that how to do the IUPAC nomenclature for a coordination compound if the coordination pair is negative, and this was how the name is written, where firstly the counter ion is written, then the ligands, and the metal is written in metallate form. Now this was the name for some compound. So these were the three questions that I did for you, and today I'll be telling you that how to write the name for a ion. Means if these compounds are totally neutral, how to write the name if an ion is given to you. Today we will see for them. So the writing of the name is same as it is for a neutral molecule, but something changes here. Let us see what are those things. Now here, let's move to the next slide here. Now in these cases, for writing the names of the ionic compound means we will be using here those compounds which have a charge on them. Like suppose I have a compound of platinum, and this platinum has 4 chlorine. This is inside a first bracket, and this complete molecule has a charge of 2 negative ones. Now we will be looking into that how to write the name for this compound. So first of all, you have to find out that whether it is a cation or an anion. First thing is that you have to determine that whether your coordination sphere means the portion which is written inside the first bracket, that is positive or negative. That is the first thing you have to determine. So since it is carrying a negative charge, it means that this is an anion. Now when it is an anion, the name is written in this type. Means first you have to write the counter ions, then the ligands, and then the metallate here. This is how you have to write if it is negative. Now in this case, here you don't have any of your counter ions. So how to write the name for this? So if you don't have the counter ion, you will be writing directly with the ligand. So how many ligands are present here? 4, and they are chlorine. So the name for 4 chlorines are, how it was written? It was written as tetra, then chlorido. Now since only one type of ligand is present, so we are done with the ligand. So now tetra chlorido. Then after the ligand, what we were to write? See, after the ligand we have to write the metal in the metallate form. So let's see. Tetrachlorido, what is the metal? Metal is your platinum. So your platinum will become platinate. Now next comes your oxidation state. Now how to determine the oxidation state? So here the determination is a bit different. You see, just as in the case you calculated the oxidation state where you have put the value of the total molecule as 0, here you see we have to determine the oxidation state of platinum. So we will be taking it as X, then plus, then how many chlorines are there? 4. One chlorine has -1 charge, so that is why 4 into -1. Now equal to, here in the previous cases we were writing the value which was carried by the total molecule. Now here it is -2, so you will be writing it here as -2. Means whatever the value it will carry, whatever the charge it will carry, that you will write on the right side. So this will be X is equal to that -2, then that will go this side, that will become +4, that is equal to +2. It means that here the charge of X is 2. So only this much will be the name for this compound. The name will be tetrachlorido platinate 2, and that is the name for this compound. Let me do another one. Another one is Ti, then H2O. This is whole 6, and this carries a charge 3 positive. Now when it was positive form, means in the cationic form, then how the name was written? Then for writing the name of a cation, we have to first of all we have to write the ligands. So the ligands are water, so it will be hexa aqua, hexa-aqua. Then after that you have your metal. Your metal is titanium. Since it is a positive, so that will be only titanium. And now you have to determine the oxidation state. So oxidation state of titanium, so this will be as x plus 6 into 0 is equal to, this is carrying a charge 3 positive, so we'll write it here 3. Now here x is equal to 3, so here it will be as 3. So hexa-aqua titanium 3. If you want, you can write it here as ion. Otherwise that is also not required. Means we are following the same procedure as we have done for the previous one. Here how the naming was done. So for doing the name, when it was positive, first we have written the ligand, then we have written the metal, and then we have written the counter ion. Now since we don't have any ion in our case, so we have directly written the names and then we have used it. Now we will be moving ahead and starting today's class, that how to do the remaining. Now this is the chart which I have already given you, that how it is named. This anionic ligand, the bromine, it has a negative, then ligand name is bromo, then carbonate or chloro, and in this way the name is written. Now today we will be starting with isomerism. Now what do you mean by isomerism? Just as in our organic chemistry we have come to know about isomerism. Isomerism means those compounds which have the same formula but different structure. So similarly in inorganic chemistry also we have isomerism here. Now this isomerism, it tells us about, it arises due to the difference in the structures of the coordination compound. Means here the structures will be different. Now isomerism, it arises due to, it can arise due to two, it means it is two types. It is of two types. One is your structural, another one is your stereoisomerism. Now this structural isomerism, it arises due to the difference in the structure, and stereo, it arises due to the spatial orientation of ligands. Spatial orientation means how they are arranged in the space that is asked now. So they are further classified. This structural one is classified as ionization, hydration, linkage, and co-ordination isomerism, whereas stereoisomerism, it is classified as geometrical isomerism and optical isomerism. Now we will be looking into them one by one. Let's see. The first one is your ionization isomerism. It arises when the counter ion in a complex salt is itself a potential ligand and can displace a ligand, which can then become a counter ion. Means here this type of isomerism will arise, and an example is given here. You see, this type of isomerism arises when your counter ion and the ligand, both of them can play each other's role. मतलब ब्रोमीन और सल्फेट अगर हम लें तो ब्रोमीन एक लिगांड भी हो सकता है और ब्रोमीन एक काउंटर आयन भी बन सकता है. तो इस तरह का आइसोमरिज्म जो कंपाउंड दिखाते हैं, उस आइसोमरिज्म को हम कहते हैं आयोनाइजेशन आइसोमरिज्म. ध्यान से देखो अगर एग्जांपल में, तो देखो यहाँ पर पहले वाले केस में क्या हुआ है, सल्फेट बाहर था, इसमें देखो क्या हुआ है, सल्फेट अंदर चला गया. देखो OSO3 दैट इज SO4 ओनली, इट इज रिटन इन दैट वे स्ट्रक्चरली, एंड ब्रोमीन यहाँ देखो बाहर आ गया, ब्रोमीन यहाँ अंदर की तरफ था. तो इस तरह के आइसोमरिज्म को हम कहते हैं आयोनाइजेशन आइसोमरिज्म. नेक्स्ट इज योर सोलवेट आइसोमरिज्म. अब सोलवेट आइसोमरिज्म क्या है? इट इज एन आइसोमरिज्म इन विच सॉल्वेंट इज इन्वॉल्वड एज लिगांड. सॉल्वेंट इज इन्वॉल्वड एज लिगांड मतलब जो तुम्हारा सॉल्वेंट है जिसमें डिसॉल्व होता है वो लिगांड की तरह इन्वॉल्व है, जैसे ये वाला वाटर वाला देखो. और ये चीज ज्यादातर वाटर के साथ देखा जाता है. जैसे यहाँ पर क्या है कि वाटर तुम्हारा एक लिगांड की तरह है जो कि कोड मतलब इसके ब्रैकेट के अंदर है. यहाँ पर फिलहाल दिस इज इनसाइड द ब्रैकेट where you can see that 6 molecules of water are there, and this is violet in color. Next is your chromium water 5 Cl2.H2O, means one H2O has come out. This is bluish green, and here 4 are present inside and 2 is present outside. So these all cases are the example of solvent isomerism, which will tell us that if water is present or not. Then now if this water molecules are present in different numbers either inside the square bracket or outside the square bracket, they impart different properties, like they will give violet color, they will give blue green color, they will give dark green color in this way. Now next is your linkage isomerism. Now linkage isomerism, it arises in a coordination compound containing M bidentate ligand. Now if you remember, M bidentate ligand means they were those ligands in which two atoms can ligate. means जैसे नाइट्रो वाला, नाइट्रो में क्या था, N डबल बॉन्ड O और O था, तो यहाँ ये नाइट्रोजन से भी बॉन्ड बन सकता है और ऑक्सीजन से भी बॉन्ड बन सकता है। तो इस तरह के लिगांड को हम कहते थे एम बाइडेंटेट लिगांड। तो लिंकेज आइसोमरिज्म दिखाने के लिए एक एम बाइडेंटेट लिगांड का होना बहुत जरूरी है। बिना एम बाइडेंटेट लिगांड के लिंकेज आइसोमरिज्म नहीं हो सकता। जैसे फॉर एग्जाम्पल यहाँ पे देखो, जैसे वो एग्जाम्पल दिया हुआ है NO2 का। अब NO2 जो है, इट कैन बाइंड अ मेटल आइदर थ्रू N एटम और द ऑक्सीजन एटम। सी हियर द एग्जाम्पल इज गिवन। नाउ दिस, अगर N से बॉन्ड बनता है तो नाइट्रो और O से बॉन्ड बनता है तो नाइट्रिटो। तो इस तरह के जो आइसोमर्स होते हैं उनको हम लिंकेज आइसोमरिज्म कह सकते हैं। दे आर लिंकेज आइसोमरिज्म बिकॉज उनका लिंकिंग एटम जो है वही उनको डिफरेंट बना रहा है, अदरवाइज कंपाउंड का फॉर्मूला सेम रहेगा। जैसे मान लो CH3NO2, ये जस्ट एक कॉमन एग्जांपल दे रहा हूँ मैं। CH3NO2 है, इसमें भी फॉर्मूला वही रहेगा। यहाँ पर दिखा रहा हूँ कि कार्बन का बॉन्ड नाइट्रोजन से हुआ है, और अगर वहीं पे मान लो CH3ONO लिखता हूँ तभी भी तो फॉर्मूला वही है, एक कार्बन 3 हाइड्रोजन 2 ऑक्सीजन 1 नाइट्रोजन। सिमिलरली यहाँ पर एक कार्बन 3 हाइड्रोजन 1 नाइट्रोजन 2 ऑक्सीजन। So there is nothing difference, just the difference is that the bonding atoms are different. So this type of isomerism is known as linkage isomerism. Now next is your co-ordination isomerism. This type of isomerism arises from the interchange of ligand between cationic and anionic entities. अब ये cationic entities में कि cationic और anionic entities मतलब होता है कि सपोज जैसे हम जब वो लिख रहे थे कि when we were writing the names of these compounds, like suppose एक coordination compound ले लेता, मान लो ये X Y और ये बाहर वाला मान लो Z हो गया। तो यहाँ पर हमारा जो काउंटर आयन है वो एक लिगांड होता है, सॉरी एक लिगांड नहीं होता, एक रेडिकल होता है या एक आयन होता है। जैसे मान लो सल्फेट हो सकता है या फिर क्लोरीन हो सकता है, ब्रोमीन हो सकता है, कुछ भी हो सकता है। बट कोऑर्डिनेशन आइसोमेरिज्म का मतलब क्या है, यहाँ पर जो तुम्हारे कैटायोनिक और एनायोनिक होंगे वो दोनों के दोनों ही कोऑर्डिनेशन पेयर होंगे, मतलब दोनों हिस्से तुम्हारे स्क्वायर ब्रैकेट के अंदर लिखे होंगे। बोथ ऑफ देम विल बी रिटन इनसाइड अ स्क्वायर ब्रैकेट एज दिस वन यू सी। यहाँ देखो, ये देखो, ये भी, ये पहला वाला जो है ये तुम्हारा पॉजिटिव है और दूसरा वाला जो है वो तुम्हारा नेगेटिव है। तो यहाँ देखो क्या हुआ, पहले वाले में कोबाल्ट अमोनिया के साथ बॉन्डेड था, क्रोमियम साइनाइड के साथ। इसमें देखो वही इंटरचेंज ऑफ लिगांड हो गया है, क्रोमियम के साथ आ गया है ये अमोनिया और कोबाल्ट के साथ चला गया है साइनाइड। तो इस तरह का आइसोमेरिज्म हमें जिसमें देखने को मिलता है उसको हम लोग कहते हैं कोऑर्डिनेशन आइसोमेरिज्म। अब अगला देखते हैं ज्योमेट्रिकल आइसोमेरिज्म। अब ज्योमेट्रिकल आइसोमेरिज्म केवल हेटेरोलेप्टिक कॉम्प्लेक्सेस में ही प्रेजेंट पॉसिबल है। अब हेटेरोलेप्टिक का मतलब क्या था, जहाँ पर अलग अलग तरह के लिगांड हैं। अलग अलग तरह के लिगांड मतलब जैसे M है, M के साथ L2 L मतलब L2 और मान लो अगर दूसरे वाले से मैंने पकड़ लिया N तो N2, मतलब दोनों लिगांड, चारों लिगांड अलग अलग होने होंगे। एक ही तरह के लिगांड जैसे ML4, इसमें ये पॉसिबल नहीं है ज्योमेट्रिकल आइसोमेरिज्म। So for a compound to show geometrical isomerism, that should be a heteroleptic complex. Like here you see this isomerism, this type of isomerism is known as your geometrical isomerism. Cis और trans अगर याद ना हो, then cis का मतलब था when the same molecules are present on the same side, और trans का मतलब था अलग अलग। जैसे मान लो यहाँ पे क्लोरीन को ले लो, ये देखो ये क्लोरीन दोनों एक दूसरे के अगल बगल में मौजूद है, लेकिन यहाँ पे देखो एक्चुअली दिस स्ट्रक्चर इज लाइक दैट ऑफ अ टेबल। मान लो ये प्लैटिनम जो है वो टेबल के बीचों बीच है, टेबल के चार कोने अमोनिया है और एक क्लोरीन टेबल के ऊपर है, एक क्लोरीन टेबल के नीचे है। तो ये दोनों ऑपोजिट डायरेक्शन में ओरिएंटेड है, तो इसीलिए इनको ट्रांस कहते हैं। वही ये दोनों जो है, ये टेबल का एक कोना है और ये तो एक तरफ से ऊपर ही है, तो ये दोनों एक दूसरे के साथ नियरेस्ट डिस्टेंस में है, तो इनको हम लोग सिस कंपाउंड कहते हैं। अब अगर और एग्जांपल दूं मैं, then if I give you more examples for this, then we can write it for a square planar complex. Square planar complex के लिए कैसे लिख सकते हैं, देखो suppose you have a molecule of suppose cobalt is there and this cobalt is bonded with your ammonia, it is bonded। यहाँ पे मान लो ब्रोमीन है, यहाँ पर फिर से मान लो अमोनिया है और यहाँ पे मान लो ब्रोमीन है। Then now you see the same type of complexes, they are arranged far from one another in X pattern. So this type of pattern is known as cis और इसका trans क्या होगा, sorry this is known as trans, this is known as trans, ये trans है। And what will happen in case of cis, cis में क्या होगा, ये दोनों एक ही साइड रहेंगे, अमोनिया भी इधर है तो अमोनिया भी इधर होगा और ब्रोमीन एंड ब्रोमीन। If you remember your first video, that is from there only. So now next comes your So that valence bond theory we will do in the next class. Now, with this we end this chapter here, and this today's class we end it here. Now, in the next class, we will be learning about the compounds of valence bond theory, and what is valence bond theory. We will be coming to know about it in the next class. Now, here we have to see that how this geometrical isomers and everything arises. So for that, I'll suggest you that you read the book, and also at the same time with this video, I'm just going to upload the notes in the campus here. You write the notes and watch the video, you get an idea about it. And thank you for watching the video up to here. Thank you for your attention. Thank you very much.